Okay, so in this video, I'm going to show off some of the context datasheet help now in MPLAB X. This works for the new AVRs, MEGA4809, for example, in the megaAVR 0 series, or the tiny817, one of the examples in the tinyAVR 0 or 1 series. Some PIC devices are coming soon as well. We're going to show off the Curiosity Nano for the MEGA4809 and show how to access some of the key documents for that, which has been built into MPLAB X. So we're going to be covering accessing the HTML datasheet, both via IOView as well as from the editor when we highlight the peripheral.register. Let's get going. So in MPLAB X, we plug in the kit. And in the kit window, we have user guide, schematics, the PDF datasheet, and series manual. Let's open the schematics. So my use case is trying to turn on a LED with a pin change interrupt on the user button. So I can see that my LED is on port F5, and I'm going to set that as an output. And I want it low to turn the LED on, and the user button, I'm going to set that as an input, and when I push the button in, it's going to pull the pin low, and I will need a pull-up to pull the pin back up. So let's start a new project. 4809. The connected kit should come up. XC8 compiler. Now we're going to need to add a source file, new other Microchip embedded, and under XC8 compiler we can see the AVR main. Call this main. Now, if we have done this before for an AVR project, we will now see the AVR main at the top there, and we can add that quite easily in the next time. So we will open IOView, and now we had port F. Port F5 was the LED. So we wanted to set the LED as an output. So if we click on dir, maybe this datasheet icon here can help us. And you can see that the register description is opened in context. Writing a 1 configures and enables the pin as an output. Note also that the reset value is 00, so that means that you only have to configure the pins that you want as outputs, but input is the default value. Going to the set register right next to it, we can see that this writing a 1 to dir set essentially does the same thing as writing to the port x.dir with a bit. So this is a slightly more efficient way of configuring the pins. Port f.dir set, and that was pin 5. And so that's the LED pin as output. And if we had come to this piece of code and we wanted to understand what was happening here, we could highlight the peripheral.register, click on the datasheet icon in the editor, and go straight to the datasheet and be able to understand that this is essentially what was being done here. Okay, so we want to enable pull-ups and interrupts on our switch pin. So if we scroll down the different registers, we can see some pin control registers. 6 was our one, but I'm sure these all described in a generic way. As is confirmed when you open the register description, we can see that there's a pull-up enable and there's an interrupt status and control. So bits configure the sense configuration of the pin, and there's a both edges where we can enable an interrupt on both edges. Now we are in the context of the port description of the datasheet, so we could go to a functional description, and there's an interrupt section here. And one interesting thing that we're going to take note of is that the interrupt flags. The interrupt request remains active until the interrupt flag is cleared. We're going to have to clear the flags manually. But first of all, port F dot pin 6 control, and we wanted to set port pull-ups, control space, yes, pull-ups, and port interrupt status and control, and both edges. If we want to change a group configuration, we first use a group mask to clear the existing configuration and then apply the new group configuration. See AVR 1000 for the recommended ways of doing this. But since we know that as we click here, Datasheet again, just to emphasize the fact that these reset value again of the pin control register is 0, so we can be confident that the rest of the bits are zeros. So let's figure out how to use ISRs or interrupts on the AVR. Microchip.com/webdoc, you can see something related to AVR libc. So in AVR libc, we want the library reference, and here you can see that there's an interrupt section. Okay, so as this section on interrupts opens, we can see the most important thing, that we need to add the right header file, AVR-interrupts, that all the interrupt service routines have an underscore vector, and that there is something here, say, for enabling the global interrupt flag. We need to do that each time we use any interrupt. Enable global interrupts. And all the ISRs were underscore vector. So we pick something like one of the group configurations, which we know is in the header file, and we can search for underscore vector, which is the pattern, and just look for one of the port vectors. And here we can see port E. So we need port F, but this will do because we just copy this to our clipboard, go back to main, and just change the port number to F. Stays blue, which means that our assumption was correct. Okay, now remember we needed to clear the interrupt flags. In order to do that, we needed to read it out. And then we can write a 1 to the relative flags by just writing this back again. Then we need a test to test if the pin is low, control space, if else not, will give us a low, and it's the port f.in, ANDed with the pin that we're checking, which is 6. And if it is low, that we've pushed in the button, we want the LED on, and so port f.out. So we out clear to make it low will turn on the LED, and that's pin 5. And to check, we can highlight this, go to the datasheet, and check, yes, that this out clears the output value, and the output value pin is driven low. So we just copy this and change it, and set, and let's see if this works. So let's debug. Okay, set a breakpoint. Yes, software breakpoints are fine. In the ISR, start it running, and let's just go back to IO view, and as we push the button, we trigger a pin change interrupt. We go into the interrupt service routine. We have released the button right now, so you can see that we haven't read anything here. We step, we can see that there's some interrupt flags, and we are checking the status of the input of pin 6, which is a 1. That will be a 1, but it'll be a 0 with this, so it will go to the else. And if we step forward, it doesn't go to the else, and it should turn the LED off as we step over this, which it does. Okay, so let's uncheck the breakpoint, set this running, and confirm that as we push the button, our LED comes on. So this is just a demonstration of how interrupts work in the AVR, but also how we can access datasheet online registered descriptions directly from the editor or from IOView in MPLAB, and also how useful it is to find the direct links to schematics of certain kits. Thank you.